Now let us continue with the question 3 here. We're given the parametric curves given by these equations. This equation, okay. Let us do the question A. In order to find the slope, right, the chain rule, if we take derivative dy over dt, it will be dy over dx over dt, right? It is a product. So the slope is this guy, dy over dx, right? Therefore, we have the formula dy over dt divided by dx over dt here. And what is dy over dt? Y is t squared plus t, right? So dy over dt is d of t squared plus t here, dx over dt, and x is t squared plus 1, right? Therefore, it will be t squared plus t derivative of that will be 2t plus 1. Of this one, it will be 2t, okay? So this is the slope of this guy, or you can simplify it. And it will be 1 plus, or let us write it slowly, it will be 2t over 2t plus 1 over 2t, or it will be 1 plus 1 over 2t, okay? That is the question A. B, find all values of t where the tangent lines is horizontal or vertical. When at the point T where the horizontal tangent, which is equivalent to saying that dy over dt should be 0, this term, right? Or and dx over dt is not 0. Horizontal tangent, it means dy over dx should be 0, which is the same as this fraction is equal to 0. That is why we have these two solutions, two things, two conditions. Okay, now if dy over dt is equal to 0, it means that dy over dt, which is d over dt of t squared plus t, is equal to 0, right? Or 2t plus 1 is equal to 0. Therefore, t should be correct, -1 over 2. Now, at t is equal to -1 over 2, then dy over dt should be 0. We need to double check dx over dt at this point at t is equal to -1/2 if it is not 0, right? Look at this. This, it will be dx over dt, which is 2t, right? At t is equal to -1/2, which is 2 times -1/2. Remember, we should write the parentheses like this, otherwise you may confuse the reader. Therefore, it will be -1, and definitely dx over dt is not different from 0, right? And the point, let us say, the point so let us say when t is equal to -1/2, right? Then x will be, what is it? X will be t squared plus 1, right? Which is -1/2 squared plus 1. And it will be 1/4 plus 1. It will be 5/4. And y will be t squared, which is -1/2 squared plus t, which will be 1/4 minus 2/4. It will be -1/4. So the point P 5/4 -4, where when t is equal to -1/2 has the slope at the curve here. Let us say the point here when t is equal to -1/2 okay, has the tangent line, tangent line at this point, let us say at a point here where when t is equal to -1/2 has a horizontal slope. Okay. That is the part 1 of the question B. Let us continue to do with the vertical tangent line, right? When we say the tangent line is horizontal, what does it mean? It means that this horizontal, it means dy over dx should goes to infinity. Or in other words, this guy dy over dt should be a constant, and dx over dt here should be a 0 approach. Yeah. It means that dx over dt should be 0 and dy over dt is not 0. Okay. So dx over dt is equal to 0 is equivalent to d over dt of t squared plus 1, right? This is x. Yeah. It should be 0, or it is 2t is equal to 0. This implies t will be 0. So double check. dy over dt, okay? At this point, t is equal to 0, which will be d over dt of t squared plus t when t is equal to 0, or it is 2t plus 1, right? Where t is equal to 0, and we substitute here, it means it is equal to 1, and definitely 1 is different from 0. Therefore, if satisfy these, we find that when t is equal to 0, then x will be t squared plus 1, which is 0 squared plus 1, 1. Y is t squared plus t, which is 0 squared plus 0, right? Which is 0. So the point P1, let us call it P1, or we use a different notation, M at 1, 0, when t is equal to 0, the tangent line at this point at the tangent line of the curve at this point, M, when t is equal to 0, has a horizontal, oh, I mean vertical, sorry. Is vertical. Vertical. Say, okay, that's it. So we have done the question B. Okay, now let us find the dy over dx already. dy squared over dx squared, for which value of t the curve is concave up, concave down. Okay, now part C. Remember the general. Okay, we want to find this. How can we do this? Okay, we know dy over dx from the part B, part A. How can we find this? So it's easy. Let us use the chain rule. D over dt of dy over dx. Okay. Again, the chain rule, it would be d over dx of dy over dt. No, dy over dx here. Times dx over dt. And this guy is nothing else but the second derivative of y with respect to x. Okay. So therefore, this guy over dx squared, it will be d over dt of dy over dx, right? Over dx over dt. Okay, dy over dx, what is it? It is found here. Dy over dx will be this guy, 1 plus 1 over 2t, right? 1 plus 1 over 2t d over dt, right? That is dy over dx. And dx over dt, and x is x squared plus 1, right? T squared plus 1. Okay, therefore, derivative of 1 would be, 0. Derivative of this guy, it is a quotient rule. Therefore, it will be negative of 1 over 2t squared. Okay, they are divided by dx over dt. Here it will be 2t. Then it is the same as negative 1 over 2t squared multiply with the reciprocal of the denominator, which is, the denominator is 2t, so the reciprocal will be 1 over 2t, right? Therefore, we have negative 1 over 4t cubed. Okay. Then this is the second derivative, right? Okay, we see that. Let us take a table how this second derivative behave when t change. T would take the value from negative infinity to infinity, right? And here the solution of the numerator is 0. Okay. So we can write this as negative 1 over 4 times 1 over, or we can write it negative 1 over 4t cubed, right? It's the same things. Here, the number negative 1 is always negative, so it is always negative. And here for t cubed, right? It has the solution here at 0. For t cubed will be 0. If t is smaller than 0, then t cubed will be, yes, negative. Negative times 4 will be a negative number. If t is positive, then this guy would be positive, right? And here, the second derivative of y with respect to x here, remember, it would be the division of this, negative divided by 1 over 4t cubed. When t is equal to 0, this fraction will be undefined, so that is why we use this notation. But when we negative 1 divided by a negative number, negative divided by negative give us a positive, negative positive give us negative. So therefore, it is concave upward when t is smaller than 0, and it is concave downward when t is positive here, right? So the curve is concave upward when t is from the interval negative infinity to 0. Remember, this is the parenthesis here. And it is concave downward when t is from 0 to infinity. That's it, okay? That is all about this question 3.